Howdy-ho, it's Andrew here, and today I'd like to teach you how to find the radius and height that will minimize the surface area of a right circular cylinder. So let's take a look. It says that a right circular cylinder has a volume of 100 cubic inches. It says find the radius and the height that will yield a minimum surface area. So essentially there's two things that we have to keep in mind. One, they're telling us about the volume, and two, they're asking us about this surface area. So I really want to create two functions. I want to create a function that describes the volume of the cylinder, and I want to create a function that describes the surface area. Let's first start with the volume. So the volume of a cylinder is going to be equal to pi times r squared times the height. Sorry, I'm feeling a little bit under the weather, so my voice hopefully will last. Anyway, so this is the formula for a volume of a cylinder. All right, if you notice pi r squared, you might recognize that as the area of a circle, and then it's basically the area of a circle times the height of the cylinder, okay? So if you notice, the top part is a circle, all right, and then the height of the cylinder is always going to be this kind of vertical height here, okay? And the radius they're referring to is going to be this radius in there, all right? So they tell us that it's 100 cubic inches, so I'm going to write it in 100 for the volume, and that's equal to pi times the radius squared times the height. Now that's really all I can do with the volume formula. The next thing is I want to now look at the surface area formula. So if you think about a cylinder, right, it has three faces, right? It kind of has three faces. It has a top face, which is a circle, a bottom face, which is also a circle, all right, and they are going to be equivalent. They're the same size circle, all right, and then you have this kind of roundabout, outer perimeter of the meat of the cylinder, so to speak, right? Not the top nor the bottom, okay? So there's three parts to the surface area, okay? It's going to be the top, I'll write the top and the bottom, okay? Maybe I should write top and bottom, plus then it's going to be the sides of the side of the cylinder, okay? Now, what's the area of the top? Well, the top is a circle, right? And we actually already said that the area of a circle is going to be pi r squared. That's just the formula. So basically the surface area would be equal to pi times the radius of the top squared, okay, plus the now area of the bottom, which is pi times the radius of the bottom circle squared, plus now the area of the side of the cylinder. Now this is kind of, I'll try to mention it here, but it might be hard to imagine. Imagine you had like a can of Coke or it doesn't matter, seltzer, right? LaCroix. Oh, I love LaCroix. Anybody like LaCroix too? For some reason, it has like the right amount of carbonation to it. I used to have like Polar and all that other stuff. I felt like I was drinking air. That was kind of weird, but LaCroix, I don't know. Anyone else feel that way? I'm lonely. Leave a comment below. Anyway, so if you could imagine taking that LaCroix can, right, and imagine you're going to cut the front, you're going to cut down the front side, okay, of the can. And if you were to unravel it, what would happen is it would look actually like a rectangle, okay? It would look like a rectangle. So the area of that rectangle then, the area is simply going to be the length of it times the width, okay? Now, if you notice, what I call the height of this cylinder is really the width, okay, of that rectangle. So I'm going to write h here. And the length now, this is could be a little bit confusing, but the length is really just the outer perimeter now. It's just this outer perimeter, okay, right? If you had to cut that on open and you unfolded it, the length would be that outer perimeter, okay? So I'll write P for perimeter, or what's the outer length of a circle called? Right, circumference, all right? So in other words, this surface area of the side face is going to be the circumference of the circle multiplied then by the height of the cylinder, right? So now, what is the circumference of the circle? Well, circumference is going to be pi, or 2 pi r, I should say, 2 pi times the radius. All right, and then that's going to be multiplied by the height, right? So the area of this little rectangle, remember, was length times width. The area then was equal to the circumference times the height. And we said that the circumference is going to be equal to 2 pi r and then that's multiplied by the height. All right. So that's what we're going to plug in. That's what I'm going to try to squeeze in on over on this side. So it's going to be 2 pi times then the radius times then the height. Now, the radius of the top face and the radius of the bottom face are both the same. So I'm just going to get rid of that. All right, top and bottom, and just call it just without t and b. All right, and also the radius here of the top face or the bottom face was equivalent, so all the r's in this equation are the same. So if you notice, if I were to add this to this, okay, I could rewrite this to look like now 2 pi r squared. All I'm doing is I'm taking these two and combining it now into this single term here. All right, and then plus 2 pi r times h. Now I could pull out, common factors here of a 2 pi and an r. I don't think that's really going to help you at all in terms of working this problem out. But this is where we're at now. Okay, so we have a formula here for the surface area. All right, this is the formula for the surface area: 2 pi times r squared plus now 2 pi RH. This is the function I want to find the minimum of. All right. And you're like, how the heck am I going to do that? Well, if you knew calculus, then we could use some techniques, but we don't know calculus yet. So we can't do that. Instead, though, what we're going to do is we're going to use the calculator, and we're going to basically plug this function on into the calculator. Now, the problem is, though, that you have two unknowns. You have a radius here and a height. You can't do that, right? Whenever you go to your calculator, you go to your y equals, and you got to type something like x plus 5 minus 2, okay? You can't plug in another variable in. It doesn't let you plug in like an a or a b or anything like that. So what has to happen now is we're going to now take this equation here. I'm going to take that equation, okay? Don't worry about the ln. We're going to take that equation, and we're going to now solve this. Probably the easiest way to do this is to solve it for h, I would think. Doesn't really matter how you do it, but maybe let's solve it for h, all right? The reason why I'm going to solve this thing for h, okay, so what would be required then is we would divide out now pi r squared from both sides. And what's going to result now, it's going to be 100 over pi r squared is equal to the height. The reason why I chose to solve for the height is because I can now take this thing and plug it in for the height there. And the benefit of that is that I'm only then going to have one unknown on this side of my equation. All right, that's why I'm doing that substitution. Now you could have solved this for r instead, but then you're left with like a square root, and you got to plug it into both here and on that side. It just becomes a little bit more complicated, but you could do it. All right, so what I'm going to do now is plug that on in. So I rewrite everything, right, and then plug that in for h. So we said it's going to be 100 over pi r squared, and now we're going to cancel some common terms. So the pi's here would go bye-bye. This radius cancels one of those on the bottom, so you're left with just r on the in the denominator there. So this is now your formula. This is now the same equivalent formula for surface area, where it is simply just a function now of the radius. Okay, so this is 100 over r. And you can combine this. What's 100 times 2? Obviously, that's 200. So you can just write this as 200 over r. All right, now, this is a function now that I can plug into my calculator. Watch, basically, now they said to let x equal the radius, but honestly, who cares? I like r equaling the radius. That makes more sense to me. But when I plug it into my calculator, I'm going to be using x now, all right? So I plug this formula in. So it's going to be 2 pi, okay, r squared, so x squared, plus now 200 divided by that r, or just divided by x, all right? Now, we're going to, I'm going to hit zoom, and I'm going to hit standard, number 6. Let's just see. Okay, so I see something on this side. I don't really see anything on the positive x-axis over here. So let's just fiddle with the window a little bit now, okay? You can't, the radius cannot be negative, right? Remember now, I said x is equal to r. So x is the radius. Can you have a negative radius? Well, no, not in reality. Either there is a radius to a circle or there isn't. So there's a minimum of 0. Let's leave the maximum radius to be 10 for now, all right? And then same thing with the minimum. for y. Now remember, basically the SA was the y, the surface area. This was like y is equal to 2 pi x squared, okay, blah, blah, blah. So can you have a negative surface area? Well, no, not in reality. Either you have a shape or you don't. Okay, so I'm going to leave that as 0. And this one I'm going to go a little bit bigger on this. Maybe I'll go 100. Okay, we'll see what that kind of gets us. And the y scale I'm going to say is 10. I'm going to step it by 10. So every tick mark you see on the graph now is going to represent 10 units of surface area. So now let's go to graph. Let's hit graph. Okay, still don't see anything, right? You don't see anything in this window. Don't fret. I just have to keep fiddling with this a little bit. So maybe I'll go to 1,000. Okay, let's go to 1,000 for the y max, and I'm going to scale it now by 100. See if oh, look at that, right? There it is, okay? So here's the function now. So what we're looking to do is we are looking to, I'll take this, I'll plug it into on the screen here, all right? What we're looking to do now is we are looking to find this minimum point. Now consider that on the x-axis we had the radius, and on the y-axis we had the surface area. All right, so what we're trying to do is to minimize the surface area. So this represents 100, 200, right, 300, because I went up to 1,000 and I stepped it up by 100, okay? So if you notice now that the minimum surface area might occur just above 100. It'll occur just above 100. Now that'll be the minimum surface area. It'll be just above 100. Okay, just above it. Now, what does that mean in terms of the radius? Right, this is the minimum point. The radius here looks like it's going to be somewhere in the vicinity of maybe 2.5. Remember, I went up by 1 unit on the radius, and it went to a maximum of 10. If you wanted to check again, hit your window, and you'll see those figures for x and y. So now you can estimate it. I don't know if you need it exact, but we can actually find it now exactly with the calculator. So watch, if I want to find the coordinates of this minimum point, what you're going to do is you're going to use your calc function here. So since it's in blue, you got to hit second and then that button. And what that does is it brings up that function calc. Now you're in the calculate function and you want to find the minimum. So you can either hit number 3 or scroll down to 3 and then hit enter. Now what it's going to do is it's going to ask you to select the point to the left of the minimum. So just move your cursor to the left of the minimum. It doesn't have to be anywhere in particular, just as long as it's to the left of the minimum. You could be out here, that's fine. You could be a little bit closer, that's fine. It doesn't matter, just somewhere to the left. Then you're going to go to the right. Same thing, just be to the right of the minimum. And now you're going to guess. Don't go crazy, just get it close. That's close enough. You might say, oh, Andrew, move over a little bit more to the left. I agree. But watch, even if I'm here, it's going to be fine. Okay, so here's the minimum. Right, minimum is right around 2.515, blah, 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 blah. Okay, so it's right around, like I said, I'm estimating this to be roughly around 2.5. All right, now sometimes the calculator could calculate this off. It might be off a little bit. Okay, but it's probably about 2.5, somewhere around there. If I was maybe a little bit more accurate, let's see if I was a little bit more accurate in my guess. So I'll go left bound again. Boom. I'll go right bound again. Okay, boom. And let me get a little bit closer maybe to where I think the minimum is. Maybe somewhere around there. Let's see. Oh, same number. So I feel pretty confident in that, okay? So the x here, or the radius, is going to be 2.515, okay? And that gives the minimum surface area now of the minimum surface area of 119.26, blah, 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 or 3, okay? Now, well, I was going to say, do you have any questions? But if you did, I wouldn't be able to answer you right now. But you could leave a comment below, and we'll try to get back to you. By the way, if you wanted us to get back to you with priority comments, we do have a membership program. You could definitely check that out. We'd love to hear from you. So now what I'm going to do is just kind of get rid of this image for a second and get back to the problem. All right, I'm going to have some other, these little things here. I'll just get rid of these numbers. It doesn't really matter. Now it said to find the radius, which I did, but it also now wants to know the height. But how can we now find the height? Well, we could do this in a couple of ways, but probably the easiest way is to use our formula we have here, right? This formula here is already solved for the height. It says that if you know what the radius is, you can just plug it in and find the height. Okay, so the height here is going to be equal to 100 divided by 2 pi times the radius squared. As it's no, not 2. Sorry, 100 times pi times that radius squared. Okay, which is going to be just 2.515 squared. Okay, so we plug that on into our calculator. Okay, let's clear this on out. And what you do is 100 divided by, now you can use parentheses because you got to divide that whole denominator. So pi times 2.515. And we're going to be close enough here, ladies and gentlemen. Won't be exact, but we're going to be good enough. So there's going to be 5.03. All right, and that is then indeed the height. So in terms of the answers to this problem, the height here is going to be a little bit over 5, and the radius is a little bit over 2.5. And that gives the minimum surface area. And that's it. All right, so without calculus, we're able to do this problem. Listen, so thank you so very much for tuning in. I really do appreciate it. I do hope this video helps. And if it did, we have thousands of more videos out there for you because we want to help you in other subjects. All right, we kind of walk you through step-by-step actual solved problems because guess what you're going to see on your test? Problems. All right, if you want to become a good problem solver, if you want to know how to really ace those exams, we're here to help you. We're here to guide you. All right, we have a lot of resources. And we're constantly building them. So reach out, leave us a chat, or is it called a chat? Leave us a comment. There you go. Leave us a comment, and I look forward to hearing from you. Be well.